Lecture 21st, torsion. Define a 1-2 tensor S. You see, T hash, Tij, dxi, tensor product dxj, tensor product partial of derivative with respect to xk. This is a map. More precisely, a 1-2 tensor can be written, be expressed in local coordinates as T hash, in this case, just to rewrite over here. So there's a map where the domain is chi-m. There is the two vector fields, and the codomain is xm, which is one vector field. You see, that's a definition, okay, of this tensor as we derived in previous lectures. Now, let's action on vector x and y. You see, let x, xi partial dxi, y, yj partial dxj. This is the domain. T hash, x applied to x and y. This is a codomain. You see, the right hand side here is a codomain. Now, let's apply the T hash to x and y. T hash x and y, you see, this is TIM dxi, the tensor product dxj. Now this applied to x and y partial derivative with respect to xm. So this dxi, in this case, applied to x, dxi, I call xp partial derivative with respect to xp. This is equal, now this here is the chronic delta ip, which acts on p leads to xi. Xi are the contravariant components, okay, of the vector x. The same dxj act on y, dxj, yq in this case, partial of xq is yq. This is chronic delta, acts and leads to yj, also is a contravariant component, belongs to the vector space. Now I can group dxi, tensor product dxj, acting on x and y is xi yj. Now this, then I substitute over here, then the T hash acting on xy is just the right hand side, tijm, xi, yj. Attention, this is a vector, okay, this is the vector field, you see. This is partial respect to xm, I call this relation 1. Now, the goal, we want to see how the definition matches with the formula in local coordinates. You see, T hash, applied to x and y, this is a covariant derivative, okay, of y, covariant derivative of x minus the Librecht. You see, I want to match this over here with the definition, with this formula. I would say this is by inspection. So it's better to say this word. You see? Now you see the correspondence between the 1 and 2. You see? So expand in local coordinates. You see? I will expand each term over here. You see? And this must lead to this relation 1 over here. So that's that I want to see, okay? So this is why I have the interrogation mark over here, the codomain. Now then each term, you see, just you know that the covariant derivative respect this to the basis, okay? Basis vector acting on y is just this relation here, which you already know. You will discuss this a lot. The same partial, this is a covariant derivative, this is the basis vector, see, partial j x. The same, it's the same here. Now attention, you can see that JR are dummy indices. Here, IS, you see, are dummy. You see that multiplied by R, you see, there's I'll have here, okay, this J over here, this expressed on the left hand side. Now the Lie bracket, you already know the definition, you see, is xi partial xi ys minus yj partial xj, this xs. There's a vector, you see, that's a vector, okay? Now this is a scalar, this is a vector. So here I just I derive this, then I jump, okay, this to this here, okay, and I jump this to this there. Quite easy, you see. So these are equation 3, 4, and 5. Now you observe that equation 2, you see, equation 2 over here, you see, is equal to 4 minus this 5 minus 4 minus 3. You see, 5 minus 4 minus 3. You see, you just in the Lie bracket here cancel with this term here. You just copy this and see clearly, okay, what I'm talking about. So this leads to this relation here, xi, that's a green mark, minus yj, that's the blue one. You see, what is left is the blue and the green, which I wrote right there. So I call this equation 6. Now I will match 1, this case, and 6. This leads exactly to this relation here, which is a very, very, very important relation, you see, because this again, Tijm, I compare, you see, and see that Tijm is the difference between this. So the abstract definition 1, this abstract definition 1, okay, in general in the literature you see this, okay, so can be used to compare the torsion, okay, because this is a definition of a torsion. This, I would say, by inspection. One important relation here, for torsion-free, Tijm is set to be 0. So the Christoffel symbols are symmetric, okay, under these two indices, ij and ji. Torsion-free, this is 0. This leads to the symmetric Christoffel symbols, which we use in the literature when we develop other types of curvature. You see, this is a torsion. When I say types of curvature, we say Himanic curvature, Ricci curvature, scalar curvature, which is quite useful in relativity theory. Okay, that's it.